What is going on, guys? In this video I will teach you guys how to use an op amp to convert a current source into a voltage source. But before I begin, I would like to explain what is a current source. So the model for a current source is like this. This is parallel with its output resistance, Rs. Ideally, in a current source would have an infinite output resistance, but in reality, if that's not the case, then that can influence how you want to approach this design. So you want to measure IS. So usually you probably want to put a resistor, R load, and some current will flow this way. Let's call this I out. And the important point is some current will flow this way and some current will flow this way, and depends on how big is your output resistance of your source compared to RL, because I out here is equal to IS times RS over RS plus RL. If this is not ideal and this is smaller, really small compared to your RL, then very little current will flow this way. So non-ideal case, I out can be small, very small, and that's not very good. And generally, this is not a good design. So what you want to do is you want to use an op amp, and from what we learned so far from this right here, we want RL to be very small, very small. So what's the ideal case? RL equals 0. But how do you get a voltage if RL is 0? Well, that's where the op amp comes in. So let me move on to the next page. So we want 0 input resistance. And this is where the op amp comes in handy here. We make this our ground. So this is 0. Our pseudo ground is 0 here. And our input current goes in the negative terminal like this, and it sees the Rn of this whole thing. It sees the 0 input resistance, which is excellent. But for the feedback case, a feedback loop here to the output, you use an RF resistor to amplify your current source, and that will convert to a voltage source on the output here. So the current IS will continue to flow this way. Your IS will be 0. This is KCL, by the way. We're using KCL at this node. KCL. So IS equals to 0 volts minus V out over RF. So you have IS equals to minus V out over RF, or V out is equal to minus IS times RF. This is your input, and this is a voltage output, a current to a voltage. So this is your simple but effective current to voltage converter. Alright, I guess this is it. Leave a comment if you have any questions. Thanks for watching. See you next time.